Basic soldering techniques. Before we start, I want to go over some basic procedures. One, anytime you use open flame, you must have a fire extinguisher near you. It has to be class ABC, and it must be certified by the fire inspector. The next tool that we will use is either sandpaper or cleaning tools that are specifically designed for cleaning the pipes. This would be primarily copper pipe, 1/2 inch or 3/4. The next tool is a cutting wheel, which cuts the pipe, pair of pliers, steel tape, solder, flux with a flux brush, and propane fuel with a torch and a striker that gives flame. The first process that we're going to be doing is cutting the pipe. I have several pieces that I cut ahead of time and clean them for this demonstration. What I'm going to do is take my tape measure and measure a 6-inch piece out. I will mark it on the pipe. For an example, also, if I have 2 pieces of copper that I've got to run in between, I do not measure from end to end. What I do is I will run it in 1/2 inch and 1/2 inch. So the distance between these two would be 15 inches. The reason for that, if I take a piece of copper, stick it into my elbow, put a mark on here with my pencil, pull it out, I am roughly 1/2 inch in. So we're extending it 1/2 inch or 1 inch bigger than the actual measurement. So remember that when you are figuring out your pieces or you're putting pieces in between each of the fittings. What I'm going to do is go to my mark. This cutting wheel is a very important tool. You do not force it, you let the wheel do the cutting. General rule of thumb, let's put the blade onto the pencil line. When I start, it's clockwise and then counterclockwise. 1/2 a turn. Clockwise, counterclockwise. I want to make sure that I go all the way through it. Should have no more than 5 pounds of pressure on this at any time. This wheel, if it gets bent or out of line, you can replace the wheels with the replacement wheels, but they're expensive. Now I can tell that this is just about all the way through the way it's turning. Now this is actually a run. This is what happens. This is perfect. If you see that the wheel ran off on it, this is something that happened when I made the turn. It moved on here and actually double threaded and almost created a thread on it. So let's try this again. 6-inch piece. Checking the wheel to make sure there are no burrs in it. Now this one's being threaded. You can see the cut line all the way through here. All right, for cleaning purposes, you can haul out the inside. What ends up happening if you don't do that and you get one of these burrs in here, for an example, if you don't see this, this could be caught into the solder joint, okay? And if we put our fitting over it, what ends up happening is it creates a whistle, a Venturi effect that's on it. It'll create, if you can see on the inside, this will actually vibrate and whistle in your pipes. That's what it's caused by, is by the burrs. Next phase, I always like to use the sandpaper. There's 2 ways of doing it. Cleaning the outside, I usually go anywhere between 3/4 inch and 1 inch down. The other way I can clean these is by using my pipe cleaner, sticking in and rolling it, and these ones is actually wrecked already. Again, both sides. I did clean these prior to, but to clean the inside of the T's. Place it in, turn it, do every complete side. I want it as shiny as possible. Now I'm at the point to flux every one of my openings. The first one that I'm going to flux is all the ends. I want to get an equal amount. Don't worry about putting it on too heavy. Go around the pipe. You always do both sides, depending on your fittings that you're going to be placing in. Three fitting size. As you can see, I'm going to get double contact from the tubes and the fittings. There's a little trick on here. One of the things that I've seen the kids doing on here is that this T is out of skew. Use your existing pipe, straighten it up. You can do two things. You can take a pair of pliers, squeeze them together so it locks it in place. Usually hit the T's. You don't want to do it so much that you deform it, but enough for it to grab and hold. Soldering. Again, this is where the fire extinguisher comes, the most important part of it. All right, for this example, what I'm going to do is take the solder out. I give myself enough room and I put a hook on it for soldering on the back. We're going to do a gravity joint. 9 times out of 10, you're not going to have a flat surface that you're going to be able to place it to. You will probably be soldering pipes in effect. When we solder, the flux will take this up into the joint itself. Do this joint next, this joint, and we work our way out. For striking, keep it low, start it. Now, what I'm looking for the flame, the hottest part of the flame is the blue. If you can see that, that's where I'm going to stick the flame in. It's not way out here. You see the flame right here, the hottest part is the blue. It's not out here, it's right there. Now when I'm going to solder, I hold the flame on the opposite side of the flux. I wait until it's good and hot. You see it's starting to flow. The next joint, watch it flow down. Now, what ends up happening, I want you to see the flow of the flux on this corner down here. Let me turn the pipe a little bit. All I'm doing is touching it. Do you see how it flows all the way around? You don't need to put a lot on. Normally what I would do is have a rag to wipe the joints to clean them up. Alright, now that the product's cooled down, we can take and we can clean the joints. Normally you wipe the joints when they're hot. I don't want the class doing that. I want to show you the difference between a good joint, a poor joint, and something that's not acceptable. The very front of this joint is the type of joint that I want you guys to do. If you see the flux all the way around there, it's an even coat, it's cleaned up. This joint is not bad either. You're going to have a little bit of cut or overrun, or this one. The one that is poor, excuse me, it was the opposite. This one is a poor joint. If you can see, the solder dripped down and it looks unprofessional. Same thing with this one. You want to keep it as clean as possible when you're soldering. Using more flux does not necessarily mean that you can create a better solder joint. You want to do it well enough that you get a solder joint that fills all the way in between the pipe and the fitting, but it's not leaving a mess. Again, this first joint on the T is pretty good. And the joint up here on top is pretty good. If there's any questions, you can call Home Maintenance, Derek Zabel, or Brian Deblek, and have a nice day.